Hi everyone, a very good morning to all. Now the question number 57. It's all about total internal reflection. So the very first thing is, what is total internal reflection? So when light enters from, when light tries to enter from one medium to other, but reflects back to same medium is called internal reflection. If all the incident light reflects, then it is called total internal reflection. When light tries to enter from one medium to other but reflects back to same medium is called internal reflection. If all the incident light coming back to the same medium, then we call it as total internal reflection. Now, to occur total internal reflection, light should travel from denser to rarer medium. That is the first condition, then only it is possible. And if you consider this is denser medium, this is rarer medium, and at one point of incidence, let's say light incident at an angle I1. Now it deviates at an angle R1 which is greater than I1. Because denser to rarer means light bends away from the normal. Now you take slight greater incident angle, then the refraction angle even becomes more. Now, like that, when you keep on changing the incident angle at a particular angle of incidence, the refraction angle becomes exactly 90 degrees, and that corresponding angle of incidence where the refraction angle becomes 90 degrees is called critical angle. Now, if the angle of incidence is, let's say, I4 greater than C, then the total light reflects back. That is called total internal reflection. That means the condition is should go from light should go from denser to rarer, and angle of incidence should be greater than or equal to critical angle. Then only total internal reflection takes place. This is the definition of critical angle and condition for total internal reflection to occur. Now, when you consider the critical angle, so the formula is sin C equal to mu rarer by mu denser. If rarer medium is 1, that is air, then critical angle for any medium is 1 by mu. So critical angle formula for any medium with respect to air formula is sin C equal to 1 by mu. Otherwise, the general formula is mu rarer by mu denser. Now, what are the various cases in which we can apply total internal reflection? See, the glittering or glittering of diamond is due to total internal reflection. The shape of the diamond they cut in such a way that all the light reflected back within the medium so that it always has more light inside. That is what we call it as the total internal reflection phenomena inside the diamond. And in case of prism, like when light falls at particular angle, sorry, light falls and here it will reflect back. Here at this point it is taking total internal reflection and here and here. So this is possible at a particular case. So using total internal reflection, we can deviate light through 180 degrees by adjusting the refractive index, by adjusting the angle of incidence. And optical fiber is like a device to just like a narrow tube through which when light enters, then it will undergo multiple reflections. So it is coated by some material such that that refractive index is lesser so that the light tries to enter from denser to rarer medium, so that there is a chance of total internal reflection can happen, so that the angle of incidence will be such that the total internal reflection should take place, so that the light keep on takes multiple reflections and emerges only from the other end. Just like in endoscopy, they will use this phenomena. And the mirage formation, like when you mirage formation, there also we explain with the help of total internal reflection only. Mirage formation. So in a simple way, when you look at far distance in very hot summer day, there it looks like there is some water. That is because of total internal reflection of light. So that is what we call it as mirage formation. So like that some applications are there. And the most important question based on the total internal reflection is like field of view of fish. So when you consider this is water surface and here one fish is there. Now the field of view of fish when it looks normally, so it can view the outside world through particular circular surface only. That is called field of view. Like the fish is at a depth h. Now the light it is going to like this. So remaining will go like this. So it can see the whole world through this area only. And this is called critical angle because at this point the angle of refraction became 90 degrees. So that this is also critical angle. Now here sin C equal to mu rarer by mu denser, that is nothing but 1 by mu, because here mu rarer is air 1, mu denser is mu water. Now from this triangle, right angle triangle like this is h and this is radius of the circular shape through which the fish can see the world, and this is critical angle. Then if you take the sin C equal to opposite by hypotenuse r square plus h square. So if you equate both of them, 1 by mu equal to r by under root r square plus h square. So this is the relation. Sometimes they will also ask the area how much. What should be the area? What is the area of the field of view of a fish? Or sometimes they will ask same question in another way, just like they will ask one bulb is placed, like you imagine one bulb at the place of fish. Now the light is emerging out. So through what surface area, means what circular surface area on the top of the water surface if you cover, so that no light will emerge. That case also they will ask, like radius or area of the circular disc with which we can cover so that no light will emerge out of the water. So like that, questions can be asked based on the total internal reflection concept. Let's see few examples based on these things. The very first thing is an isotropic point source is placed at a depth h below the water surface. A floating opaque disk is placed on the surface water so that the bulb is not visible. Just before I said, so now there is a bulb at a depth h. Now we have to cover this with some circular disc of radius r so that the bulb is not visible. What is the minimum radius of the disc? As we have taken just before formula, r by under root r square plus h square. So they are asking the radius, so square both sides. So r square by r square plus h square, so that r square plus h square equal to mu square r square. So you take r terms one side, h square equal to mu square minus 1 into r square. So r equal to h by under root mu square minus 1. So this way you can solve the simple questions based on either fish or bulb. They can ask even radius also. They can give numerical values also. Now here one more thing, a small coin is resting on the bottom of a beaker filled with a liquid. A ray of light from the coin travels up to the surface of the liquid and moves along its surface. That means here, according to the given diagram, see the coin is here and the light went and this is 3 centimeter, this is 4 centimeter, this obviously 5 centimeter, such that here it became straight. That means angle of refraction became 90 and this is angle of incidence and this is angle of incidence. And from the diagram, sin I by sin R, sin 90 equal to 1 by mu. So here I value, how do we find is from this right angle triangle. So sin I means opposite by hypotenuse 3 by 5. So mu value will become 5 by 3. So that the speed of the light in liquid means medium, that is c by mu. So 3 into 10 power 8 by 5 by 3. So nothing but 9 by 5 into 10 power 8 meter per second. So from the given condition, if you can find refractive index, then you can find the speed of light in that medium. That is actually basically they are trying to ask in the question. Now similarly, the next question is, an optical fiber is surrounded by a glass coating. The critical angle for the total internal reflection. As I said, when you consider optical fiber, it is coated with some layer. Now this is mu 2, this is mu 1. Now sin c equal to mu 2 by mu 1, where mu 2 is 1.5 by 1.7. So that sin c equal to 15 by 17. But here no option is there. Then you do one thing. You just multiply with 5 divided with 5. 15 5s are 75 and 17 5s are 85. So C will become sin inverse 75 by 85. So see, when you get the answer, it is simple, but there is no option was matching. With the simple manipulation, we got the answer. So sometimes they confuse us with the answer options given, so that you have to be careful. Now the next thing is, a glass slab is immersed in water. What will be the critical angle for light ray at a glass water interface? So now refractive index of glass with respect to air is 1.5 refractive index of water with respect to air is 1.33, nothing but 4 by 3. Then refractive index of water with respect to glass equal to mu W by mu glass, that is 4 by 3 by 1.5 means 3 by 2, that is 8 by 9. Now sin C equal to mu W by mu G equal to 8 by 9 implies C equal to sin inverse 8 by 9, nothing but sin inverse 8 by 9 means 0.887. So according to the value they have given is 62.5 degrees. So they have given data because we don't know this value. We know only some particular values only. So in that cases, they will mention the value whatever required, or else you can keep it as it is like sin inverse 8 by 9 depending upon the options. Now one last and final question. A glass cube of edge 1 centimeter and mu. So one glass cube and refractive index is 1.5 has a small spot at the center. The area of the cube face that must be covered to prevent the spot from the being seen. So now here one glass cube is there, side length 1 centimeter. Now the spot is at center. So the depth is h, where h value is 1 by 2 centimeter. Now you have to cover it with some circular area of radius r, as we have seen the formula. So the mu equal to r by under root r square plus h square. Now mu value given. So if you square both sides, mu square r square plus mu square h square equal to r square, so that r square value what it will become is 1 minus mu square, h by under root so here we have taken little wrong formula, 1 by mu, so that what it will become is, just cross multiply it now, then mu square r square equal to r square plus h square, so that r square will become h square by mu square minus 1. Now they are asking area. Area means pi r square. So pi h square by mu square minus 1, where h value is half centimeter and mu value is 1.5 they have given. So if you substitute and calculate, then you will get the answer. So this is how you need to solve the questions based on critical angle or total internal reflection or field of view of a fish, or how much area, circular area should be covered on top of water surface to prevent light coming from a bulb placed at a depth h, the area or radius they can ask. So similar questions I have given as an assignment. So please try to understand and try to solve. And sometimes they will also ask questions based on the total internal reflection condition along with prism, that we will see when we study the prism concept. So only one question is there based on this in the NCERT. Just try to solve it. So thank you all of you. Will continue in the next lecture with the next question.